Pradnya SABLE, student of TE Chemical, along with my group mates ASHISH, HARSHADA, JITENDRA, HARSHAL, HIMANSHU, RAJKUMAR, present you the model for the nuclear power plant. In India, there are 20 nuclear power plants and 450 all over the world. Uranium is used as a fuel all over the world. The main equipment in any of the nuclear power plant is the reactor, heat exchanger, turbine, generator, powerhouse and condenser. The main equipment and the most important equipment of any nuclear power plant is the nuclear reactor. The nuclear reactor is made from a thick cantonment board, that is the outer cantonment building and the inner cantonment building. These two buildings are separated by 1 meter apart, in which the negative pressure is created. The heart of any nuclear reactor is known as a calandria. The calandria is made of uranium fuels, which is responsible for the electricity generation. Number of uranium fuels are brought together to form the tubes, and number of tubes are formed together to form the bundle, and the whole assembly leads to the formation of the calandria. The tubes and the calandria is made from a zirconium alloy, as the zirconium alloy has a property for resisting the radiation. The fission and the fuse or the chain reaction which is carried out inside the reactor helps the D2O or the heavy water to heat under the pressure. The temperature inside the reactor is 300 to 350 degrees centigrade and the pressure is 100 kg per centimeter square. The heated D2O is then sent to the heat exchanger. The heat exchanger is of the shell and U-tube type, in which the D2O flows from the tube side and the DM water flows from the shell side. The DM water absorbs the heat from the D2O and the steam is generated. This steam is then sent to the turbine with the help of the pressure difference. The steam then allows the turbine to rotate. There are two types of pressure turbines, that is a high pressure turbine and the low pressure turbines. The steam helps the turbine to rotate and it converts the mechanical energy into electrical energy. The unsaturated steam is then sent to the condenser, from which the heated steam is inside the tubes from the tube side and the DM water from the shell side. The condensed steam is then sent to the heat exchanger, making a closed circuit and increasing the efficiency of the heat exchanger. Then the turbine rotates and the further it is brought to the generator where the electricity is generated. The electricity is then sent to the powerhouse and electricity is distributed to the nearby areas. The plant has a capacity to generate thousands of megawatts of electricity. Safety measures have been taken for the people working inside the plant and outside the plant to protect them from the radiations. Thank you.
Hello everyone, my name is Madhurika Dashputre and these are my co-partners Yash Desai, Akhilesh Walke, Bhakti Bhatt, Prashant Pagar, Yashashri Vadkar and Vineet Balan. The process depicted here is the biostill process. In the biostill process, the three main raw materials are water, molasses and yeast. Water and molasses are mixed in equal proportions in the mixer. This is done to achieve the concentration of sugar from 15 to 20%. This mixture is then forwarded to the fermenter. In the fermenter, yeast is also added along with an anti-foaming agent. The anti-foaming agent used is turkey red oil. The residence time in the fermenter is around 6 to 8 hours. Ethanol broth is withdrawn as a product from the fermenter from the bottom and sent to the centrifugal separator. In the centrifugal separator, the yeast is recycled back to the fermenter, whereas the ethanol mixture is sent to the flash column. CO2 is removed from the top of the fermenter, whereas aldehydes are removed from the top of the flash column. The concentration in the fermenter is around 6 to 10%, whereas in the flash column the concentration achieved is 40%. From the flash column, the product then moves on to the analyzer column. The temperature in the analyzer column is around 80 degrees Celsius. A feed preheater is added to increase the temperature from 32 degrees Celsius in the fermenter to 80 degrees Celsius in the analyzer column. From the analyzer column, the feed or product obtained is then sent on to the rectifying column. The product purity obtained in the analyzer column is 90%, whereas the purity obtained in the rectifying column is 95%. The product is withdrawn from the condenser and then sent to ethanol storage. From the storage tankers are used to evenly distribute the product.
We are making a model with my colleagues. This is this is Ankit Gauri, this is Ajit Rathod, this is the Mangesh Shedau, this is the Punam Khawle, and this is the Ganesh Hakim. Firstly, crude oil which is to be stored in the storage tank, which is to be sent this heat exchanger. Firstly, heat exchanger, utility of this heat exchanger is the boiler. In this boiler, steam which is to be produced and sent to this heat exchanger in the tube size. In this heat exchanger, crude oil is to be heated up to the 100 to 120 degrees Celsius. Then after that, this crude oil is to be sent into the desalter. In this desalter, the basic purpose of this desalter, which is to be remove the salt content which is present in the crude oil. Then after that, here the temperature which is to be reduced up to the 20 to 30 degrees Celsius. Then outlet temperature of this desalter is 100 to 120 degrees Celsius. Then after that, crude oil which is to be sent in this heater furnace. Here the basic purpose of this furnace is to heating the crude oil up to the higher temperature near about 350 to 400 degrees Celsius. After that, crude oil which is to be sent in this fractionation column. The feed temperature of this crude oil is 375 degrees Celsius and 1.5 to 2 atmospheric pressure. In this fraction, the tower is called as the rectification section, and bottom side of this column is called as the stripping section. In this distillation column, the bubble capture is used, and firstly, the actual process which is to start, more volatile component which is to be firstly vaporized at the top of the ADO plant. This vapor which is to be condensed here. This is the arrangement of the series of condenser. Actual process which is into the distillate tank. Firstly, at the 30 degrees Celsius, gases which is to be formed, which is collected here, storage tank, distillate column. Then after that, simultaneous product which is to be formed at the second stage, gasoline is to be formed, and then which is to be collected here. Second, kerosene distillate tank. Then fourth is the diesel which is to be collected and stored is the diesel distillate tank. And then after finally is the lubricant oil which is to be collected and sent to this lubricant storage tank.
Hello, myself KUNAL with my co-members TEJAS UTTAKAR, ANIRUDDHA VARALE, SHASHANK Singh, SYED BELAL. We are going to explain about sugar industry and its unit operation and unit processes, and the next part will be covered by Aniruddha.
Good morning, my name is Aniruddha. I am going to explain the model of sugar industry. The cane is cut here in shredder. This is shredder. And after cutting, the feed is passed through the rolling mills. The main purpose of rolling mills is to extract more and more juice. The feed is sent to the next rolling mills, and the process is same. The remaining, after the last rolling mill, the remaining wastage is called as bagasse, which is sent to the boiler as furnace fuel. The juice is collected in mixed juice tank. The mixed juice is sent to the heaters, where lime and sulfur is also added for maintaining the pH at 7. The juice is heated up to 70 degree. After heating, the juice is sent to the clarifier. Clarifier is done by sedimentation process. The mud settled down is sent to the vacuum filter, which is for extraction more and more juice by using vacuum pipes, and the solid deposited on the vacuum pan is called as filter cake, which is used as fertilizer, and the juice cleared here is called as clear juice, which is sent to the evaporator, which is having 15 to 16 degree bricks. Main purpose of evaporators is to increase the concentration up to 60 degree bricks. These are the forward feed evaporators. The process of evaporator is start with the first body of evaporator, which is also called as semi-Gesner. This is the most important body, also the largest body in the evaporator. After the process of evaporation, the feed is sent to the vacuum pans. The feed is now called as syrup because it's much thicker than the mixed juice. The syrup is sent to the vacuum pans. The process of crystallization starts here in the vacuum pan by the boiling process. After the vacuum pans, the charge which is called as mass heat is sent to the crystallizer. In crystallizer, there is a main process is to cooling the mass heat as well as the crystal size is grown, and then the mass heat is sent to the centrifugal machine where the molasses and the sugar is separated out. The molasses collected with these pipes is sent to the molasses storage tank, and the sugar collected here is passed to the silo with vibrating screen for drying purposes. The silo is nearby silo is also grading is used for the ready packing is done in bags and the storage in storage tank. Thank you.
Today we are going to explain on the topic manufacturing of acetylene by valve process. Myself Shelly Thomas, Sanket, Praveen, Manish Pawar, Trupti Nikam, Praveen Chavan, Shweta Bharbai and Priya Rakshay are going to explain on the topic. The steam comes from the boiler at a pressure of 40 atmosphere and flow rate of 7000 kg per hour, which along with the hydrocarbons is passed to the furnace. In the furnace there are three main compartments. In the first compartment, preheating takes place. In the preheating, it is such that the temperature is increased to about 1450 degrees C. Therefore, the half of the temperature is attained in the preheating. Then it is further passed to the thermal cracking compartment 1. Here the steam is recycled and it is further passed for recracking in the thermal cracking compartment 2. And now this stream further passes to the HE. In the HE, the flow rate is about 1450 degrees C and the temperature is about 1035 kg per hour. The water is also fed in the heat exchanger so as to reduce the temperature. Now from the heat exchanger, it is further passed to the carbon trap. In the carbon trap, the water is passed from the top and the carbon black is absorbed in the tar trap. This is further passed to the compressor. In the compressor, the pressure is increased because the criteria is such that the EP has to have a pressure that is high and temperature should be low. Therefore, the pressure is increased in the compressor. Now after that, the streams goes to the EP, that is electrostatic precipitator. In the electrostatic precipitator, the charged impurities are removed. Then after passing through the electrostatic precipitator, it further goes to the absorption column 1. In the absorption column 1, the polymers of C2H2 are absorbed and removed because there is a solvent that is passed into the absorption column, that is DMF. DMF is dimethyl formamide as it is highly soluble and is a good absorber. The C2H2 polymers are absorbed in the absorption column 1. Now after that, it is further passed to the absorption column 2 where for obtaining pure C2H2 we pass it through the absorption column 2. Now after this, it is further passed to the stabilizer where the temperature and the pressure conditions are maintained so as to obtain C2H2 only in the solvent, that is DMF. Then after that, it is passed to the stripping column where the C2H2 gas is removed from the top and the solvent is removed from the bottom. This solvent is further again passed to the for purification to the boiler. Thank you.
Welcome friends, myself Sushant, my co-partner Sagar. Pradeep, Rohit, Sagar, Vaibhav and Vishal. As the process starts from the raw material, that is sulfur, molten sulfur, the molten sulfur get feed into the furnace where it is burned in the presence of oxygen at a temperature about of 1093 degrees Celsius. So we get the SO2 in gas. As it is an exothermic reaction, the SO2 is very hot. So for cooling it, we are passing it in the heat exchanger 1 where it gets cooled, and afterwards the outlet from the heat exchanger 1 is went to the converter. As the converter is a multi-stage converter, we are having 3 beds of divanadium pentoxide. Here at the first bed we are getting 63% to 65% of conversion. At the second bed we are getting 80 to 85% of conversion, and at the third bed we are getting 98 to 99% of conversion. Here SO2 is getting converted into the SO3, as it is also an exothermic process. So while taking out the SO3 from the outlet, it is very hot. To make it cool, we are passing it to the heat exchanger flow. After that the SO3 is going to the absorption tower. It is a oleum absorption tower where we are feeding concentrated H2SO4 which absorbs the SO3 and become H2S2O7, that is oleum. Then it is went from the chiller to the oleum storage tank where it is to be stored. After that, in the reaction between concentrated H2SO4 and SO3, there we are having some spent gases, that is unabsorbed SO3 and unabsorbed SO2 as well as N2. That spent gases are used as a feed into the absorption tower second, means that is acid absorption tower. In that the spent gases, and we are feeding dilute H2SO4 that absorbs the spent gases and it becomes concentrated, that is went from the chiller to the sulfuric acid storage.
Hi everyone, myself Sridhar with my group members Roshan, Sumit, Tushar, Palash, Priyanka and Savita.
This is the production of urea. CO2 is compressed up to 160 kg per centimeter square. This is reactor. Then compressing the CO2, this is fed to the reactor. This is ammonia tank. Ammonia is compressed up to 239 kg per centimeter square by this 2 reciprocating pump and then passed to ejector and fed to the reactor. This is reactor. This is plate type of reactor. CO2 is in gas form, that's why it is fed from bottom of the reactor, and ammonia is at liquid form, it is fed from top of the reactor. This is a sieve-place reactor. These plates are used for better contacting and increasing the resident time of reactor. In urea production, two reactions takes place. First reaction, ammonia is react with CO2 to form carbamate, and then carbamate is dehydrated to form urea. First reaction is exothermic, second is endothermic. After that, urea's product is formed. We remove at bottom of the reactor. It contains 33% urea. Then urea is fed to the stripping section. In stripping section, unreacted ammonia is removed from top and product is removed from bottom. After that, this is MP and LP. Working is same, but difference is that this is MP means medium pressure decomposer, LP means low pressure. Here the pressure is more than LP. In MP, unreacted gases are removed from top, and bottom product contain bottom product urea contains 46% concentration, which is fed to the LP at the top section. In LP, same process is occur like MP. Unreacted gases are removed from top, and bottom product we get urea, concentrations 70%. 70% concentration urea is fed to the evaporator 1. In evaporator 1, we get increase the concentration up to 95%, and that 95% concentration is fed to the second effect evaporator. Then concentration is increases up to the 99.8%. Gases, vapors are removed from top, which is sent to the wastewater treatment section. Then product we get 99.8% pure product. This is molten urea, which is fed to the peeling tower. In peeling tower, there is one bucket which have pores. That bucket is rotated at 300 RPM, which molten urea is flow downward, and in peeling tower, atmospheric air is flow from bottom of the peeling tower, which is flow upward. because due to countercurrent flow of both air and urea, there is a heat transfer takes place and molten urea is formed. And in LP, top gases are fed to the LC. LC means low pressure condenser. Here, the top gases are condensed, fed to the carbamate tank. In carbamate tank, some another gases are released from wastewater treatment that are mixed with in carbamate tank and then fed to the MC. MC means medium pressure condenser. Top gases of medium pressure decomposer are added here, and then after MC, gases are fed to the absorption column. In absorption column, that gases are absorbed with ammonia, and absorption takes place. At the bottom of absorption, liquid ammonia is recycled to the absorption column, and the top unreacted gases are fed to the CC. CC means carbamate condenser. In stripper, top gases are mixed with top product of absorption column and fed to the carbamate condenser. After that, that's fed into carbamate separator. In carbamate separator, carbamate is separated, which is at bottom, and unreacted gases, which is fed to the medium pressure decomposer. That carbamate solution is with the help of ejector is fed to the reactor, and this process is recycled.
This is Samir with my co-presenter Amar Padwar, Atik Firfide, Gaurav Lokapure, Anil Joshi and Anil Taude. So let's see the details of plant. Starting from storage section, ST1 for storage tank of coke and ST2 for storage tank of lime. Both are mixed in 60-40 proportion. Through belt conveyor, it is gone to electric furnace with a temperature around 2100 degrees centigrade. Here the CO react with 3C to form CaC2 and CO, where carbon monoxide again react with oxygen to form carbon dioxide, which is useful for the green section in our plant. Then the molten calcium carbide is going through airtight belt conveyor in pulverizer, where the size reduction is done through pulverizer. With the help of blower, it is going to the generator. In generator, water is coming from top and acetylene is coming from also top. Both are flowing in co-current fashion, where the reaction taking place CaC2 react with twice H2O, giving C2H2 plus calcium hydrate. Calcium hydrate is collected in storage tank number 4 from bottom, and the acetylene, pure acetylene getting from top, which is sent to the gas holder. Through gas holder, this is sent to the scrubber, where we scrub. Bottom both flowing co-current fashion. In scrubber, the acetylene contains some impurities like traces of ammonia, hydrogen sulfide and phosphine, which is removed with the help of water. And from bottom of scrubber, the spent acid, which is waste, is stored to waste disposal source. And the acetylene gas from scrubber contains some moisture which is to be removed. Therefore, it is passed through dryer, which contain number of beds. By using silica gel, acetylene gas is dried and then sent to the acetylene storage tank, which is our product.
Friends, today we are going to presenting our Chem-O-Model. My model name is Chemical Process Plant Layout. This is my co-partner. Our partner name is Neha, Mini, Vikas, Sridhar, and Hiran and Manoj. This is our ingredient of our company. This is security section. The job of security section is check everyone bikes, cars, and they can enter in plant. Points like admin office, canteen. In this admin office, there are some cabins of chief engineer, supervisor, account departments, like in other like that. Canteen is for workers, engineer. Next, we are going to R&D lab. R&D lab is research and development lab. Each and every product coming out from the process area, they can research on this product. This overall department is carried out by this department, is maintenance department. This is the utility section of our plant. In this utility section, there is air, pumps, coolers, and whatever process requirements they can supply to every plant. Next, we are going to discuss about chimney. This is a chimney of our industry. The main basic concept of our industry is ETP and STP. What is ETP? ETP is effluent treatment plant. STP means sludge treatment plant. In this effluent treatment plants, we are going to treatment about wastewater, and they can reuse again water to our process. This is a pump section of our process. This is our product storage. Next we are discuss about raw material storage. Raw material storage is near the inside of our main road. Next we are going to discuss about your material can be transported by train, rail wagons, etc. This is green area of our industry. Overall plant is eco-friendly plant.
Welcome, this is my plant, nitric acid production. This is my team partners, myself Shubham Munecha, Bharti, Arifa Maner, Priyanka Deshmukh, Tushar Wankhede, Sharif Pithod. So let's start it with the nitric acid production plant. We have two raw materials basically, nitric, ammonia and air. NS3 is stored in the storage tank up to minus 33 degrees Celsius, and air is feed to a reactor by compressor. The NS3 is feed by a feed pump to the reactor. The reactor has three parts basically: the converter, the superheater, and the heat recovery section. In the converter, we have a platinum based catalyst, wherein 90% platinum is there and 10% rhodium is present. And this further mixture, which is NS3 and pure O2, pass through the platinum based catalyst. In the converter, the temperature is around 800 degrees Celsius, and the reaction takes place where NS3 is converted into NO. And in further, the feed mixture is further passed to the superheater, where the NO is converted into NO2. The heat which is gained by the feed mixture is removed hence by the heat recovery boiler section, where the amount of heat which is generated extra can be removed with the help of passage of a cooling water, and the outlet of a cooling water, that is the steam which is generated by the gaining of the heat, is shown here, which can be used in the other plants wherever it is required. The feed which comes back from the reactor is then fed to a catalyst filter, where a filter is present, where we can remove all the platinum based catalyst which can be absorbed by the feed mixture. Further, the feed mixture is sent to two heat exchangers, that is tail gas heater and the steam economizer. The tail gas heater, the temperature is reduced almost about 150 degrees Celsius, and in the steam economizer, then it is reduced to 50 degrees Celsius. Here's the absorber. Here the temperature is around 50 degrees Celsius. The heat exchangers which removes the heat, then it is passed to the turbine. Where the turbine converts the water to a steam, and it is fed to the superheater. The feed which comes in the absorber column or the diluter then gets converted to nitric acid. The process is the water sprinkles up from the top, and the conversion takes place, that is NO2 is converted into nitric acid, that is HNO3. A dilute form takes place, that is 9 to 10% of HNO3 is achieved by this process. Then further, to achieve more concentration, a absorption column plus cooling column is introduced in the middle. In the absorption column, where the HNO3, which is around 9 to 10% in the purity, that is concentration, it is increased up to 40 to 50% concentration by the help of a packed bed column, which is a glass, basically cord glass is used as an absorption column, and a cooling process is also done in this column by the help of a cooling water. Then the further 40 to 50% of the concentration of the nitric acid can be stored in the storage tank. To further increase the concentration of the nitric acid, another column can be introduced, that is isotropic distillation column, where a third party component can be added, that is H2SO4, that is 100% pure. That can be easily gets transferred, that is H2SO4 will react with water, that is H2SO4 will react with water and gets converted into dilute H2SO4, and the nitric acid concentration can be increased up to 98%. So if we want further increase in the concentration, that can be done also by introducing a third equipment, that is isotropic distillation column.